Good morning, guys. Welcome back to my YouTube channel. In today's lesson, we'll be studying acid, base, and salt. And I'll be focusing majorly on the acid part. We're going to break this down. So come with me. First and foremost, what's an acid? An acid, an acid is a substance. An acid is a substance which, when in aqueous solution, produces produces hydronium or ozonium ion as the only positive ion. Yes, this is what an acid is. An acid is a substance which, when in aqueous solution, produces hydronium or ozonium ion as the only what? Positive ion. To bring this out in reality, like an equation, you said an acid is a substance which, when dissolved in aqueous solution, produces what? Hydronium or as the only what? Positive ion. So let's go with HCl, hydrochloric acid, plus water. Let's see what a combination of this will give us. Hydrochloric acid plus water. This will yield hydronium plus chlorine ion. This is basically this definition that says an acid is a substance which, when in aqueous solution, produces what? Hydronium or ozonium ion as the only what? Positive ion. These are acid, hydrochloric acid. This is water, H2O. A combination of hydrochloric acid and water gave us what? Hydronium or ozonium, H3O positive. Don't forget, we said we use what? Hydronium as the only positive ion, and chlorine, which is what? Our negative ion. Having established this, the next thing you need to take note of is what? Types of acid. Types of acid. Types of acid. We have two basically types of acid, namely the first one, organic acid, and the second one, inorganic acid. Organic acid and inorganic acid. These are our two major types of what? Acid. Let's go with the first one, organic acid. These are these are acids obtained from natural products. Natural products, that's the organic acid. Your inorganic acid. These are acids obtained from inorganic materials. Let's go back to our organic acid. We said these are acids obtained from what? Natural product. This product can be plants and animals. Plants slash what? Animals. Furthermore, examples of these your organic acids include your ethanoic acid, your citric acid, your ascorbic acid, your lactic acid. You also have your, okay, let's say amino acids, fatty acids. These and lots more are examples under your what? Organic what? Acid. Examples under your organic acid. For example, ethanoic acid is obtained from vinegar. Your citric is gotten from lime or lemon. Your ascorbic is gotten from oranges. Your lactic is gotten from milk. Your amino is gotten from proteins. Your fatty acid is gotten from fat and oil. So these are your what? Examples of your organic what? Acid. We say inorganic acid. These are acids obtained from what? Inorganic what? Materials. What you should take note of that these are inorganic acid. They can be made industrially or in the laboratory. Examples are your hydrochloric acid, you know this already, your sulfuric acid, triazonitrifine acid, any acid you can think that can be produced in the laboratory or industrially are examples of your what? Inorganic what? Acid. The next major thing I want to highlight under acid is strong and weak acid. Strong, you should take note of this. Strong and weak acids. Strong and weak what? Acid. Let's go with the strong acid first. Strong acid. Strong acid. These are acids that ionize. These are acids that ionize completely in a solution. Your strong acid. These are acids that ionize completely in a solution. Example of a strong acid is your hydrochloric acid. Another example is your sulfuric acid. Even your triazonitrifine acid is also a strong acid. How are they strong acid? When they are in a solution, there is a complete ionization of the hydrogen ion. I'll follow you. There's a complete what? Ionization of hydrogen ion. Let's say your HCl. If you break down your HCl, this will give us what? Hydrogen ion positive plus chlorine ion negative. I'm following. Acid that ionizes completely in a solution are referred to as what? Strong acid. Let's proceed further. Weak acid. Weak acids. Weak acids ionizes partially in a solution. Weak acid ionizes partially in a solution. So unlike your strong acid, that there's a complete ionization, a complete removal of the what? Separation of the hydrogen atom from the compound. In your weak acid is a partial what? Ionization. There's no complete removal of what? The hydrogen what? Ion. Example of this weak acid is your ethanoic acid, CH3COOH. If we were to break this down to give you the ionization to give us what? CH3COO negative plus H positive. This is an example of a weak acid. In a solution, it does not ionize what? Completely. There is some breakdown of hydrogen atom and there is some retention of what? Hydrogen ion. Because ethanol can only give out what? one hydrogen what? Ion. Hence is a weak acid. This is the breakdown. Still carrying is what? Compound CH3COO negative plus the one hydrogen is what? Donated. So this is an example of a weak acid. This will lead us to what we call basicity of an acid. This will lead us to what we call basicity of an acid. Basicity of an acid. The basicity, the basicity of an acid is the number of replaceable 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 hydrogen ion in a solution. Basicity of an acid is the number of replaceable hydrogen ion in an acid. That's to say, how many hydrogen atoms can be donated or hydrogen ions can be given off in an acid. Okay, let me give you guys some examples of some acid and their basicity. We have hydrochloric acid. Hydrochloric acid is monobasic. Hydrochloric acid is monobasic because it can only give out what? It only has one hydrogen ion attached to it, which is just this one, H plus. So it's what? Monobasic. Another example is your sulfuric acid. Your sulfuric acid is diabasic. Because it has what? Two hydrogen ions in the acid. So therefore, it is what? Diabasic. Another type of acid is your tetraoxophosphate 5 acid. This is an acid, tetraoxophosphate 5 acid. This acid is tribasic. It's tribasic because it has what? 3 hydrogen what? Ions. It's tribasic. And so on and so forth. So what you need to understand under basicity of an acid is what? Number of replaceable what? Hydrogen ion in a solution. And these are some of the acid. I have to list them out to give you their what, to understand what their basicity. Hydrochloric acid, basic 1 hydrogen ion. Sulfuric acid, diabasic, having what? 2 hydrogen ion. Phosphate acid, having what? 3 what? Hydrogen ion in it. Just like that, and so on and so forth. Having talked about the basicity of an acid, let's talk about what? The physical and chemical properties of an acid. 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 Let's go with the physical properties first and foremost. Physical properties. Physical properties. First and foremost, an acid has a what? A sour taste. An acid has a sour taste. Another physical properties we can take note of is that strong strong acid has what? Corrosive tendencies. So these are some of the what? Physical properties of an what? Of an acid. It has a sour taste. It has what? A corrosive tendency. There's another one point I'm trying to remember at the moment. I'm going to give you 3 points. But I'm not going to dwell on that. Let's go to chemical properties. Chemical properties of an acid. Chemical properties of an acid. One, an acid, an acid reacts with metals. An acid reacts with metals. We're talking about chemical properties now. An acid reacts with metals. In reaction with metals, in reaction with metals, hydrogen gas, let me just write H2, H2 gas, which is hydrogen gas, is liberated. We are dealing with what? Chemical properties of an acid. We said an acid reacts with metals, and in reaction with metals, hydrogen gas is what? Liberated or evolved. Let me give you an example. We have we have magnesium, magnesium in reaction with what now? Let's say HCl, hydrochloric acid, or let me use okay, I was thinking of that example. Let's just go with this one. Magnesium with hydrochloric acid. Magnesium with hydrochloric acid. This will give us magnesium chloride plus hydrogen. This equation is not balanced. That's why I was skeptical about the example. But I'm going to balance this equation and make it correct. Because oxidation state of magnesium is plus 2. So because of that, I'll put 2 here. I'll put 2 here. I'll put 2 here. When I put 2 here, I'll also put 2 here. It's still not balanced. I'll put 2 here. Yes. Because the oxidation state of magnesium is plus 2. Oxidation state of hydrogen is 1. Oxidation state of chlorine is minus 1. So to make it balanced, to make the equation balanced, I have to introduce what? 2 here. And so by doing this, you need 2 atoms of hydrogen and 2 atoms of chlorine to react with 1 atom of magnesium. Hence you're having what? Magnesium chloride. In this equation, hydrogen gas has been evolved. As you can see from the equation, are you following? Hydrogen gas has been given up. So this is an example of what? An acid reacting with a metal to give out what? Hydrogen gas. Okay? I think we can go to other chemical properties now. The second chemical property I want to look at is reaction reaction with bases and alkalis. reaction, reaction with bases and alkalis. Acids, acid reacts with insoluble bases and alkalis in order to produce salt and water. This this process is known as neutralization. But let me just write it here. Neutralization. Reaction with base and alkalis. Acid react with insoluble bases and alkalis in order to produce salt and water. And this process is known as what? Neutralization reaction. An example of this is, let's say, HCl or acid. Which person are we going to use now? We can use sodium hydroxide. You can use sodium hydroxide. You can use different bases. You can use calcium oxide and that can leave, depending. But let's make use of this one. The reaction of hydrochloric acid and sodium hydroxide. This will give us what? Don't forget, they said in the definition, they said acids react with insoluble bases and alkalis in order to produce what? Salt and water. So our product must involve what? Salt and water. Okay? Our salt here is what? Our sodium chloride. And our water, of course, is what? H2O. But is our equation balanced? Let's see.
Yes.
Yes, because hydrogen has one oxidation state, same as chlorine, same as sodium. This is an hydroxide. So it's not like oxygen standing on its own, which would have been made -2 or +2. No. In an hydroxide is what? -1. So the oxidation state for this hydroxide is -1. So the equation is what? Chemically balanced. One atom of hydrogen, that's two atoms of hydrogen, our two atoms of hydrogen, what? One atom of oxygen, one atom of oxygen, one atom of sodium, one atom of sodium, atom of chlorine, atom of chlorine. Sodium chloride is a salt. Our H2O is what? Water. So this equation explains what? Reaction with bases and what? Alkalis. Okay? Let's go to the preparation of acids. Preparation of acids. Preparation of acids. We can say by number one, by direct combination. By direct combination. Preparation of an acid. We can say one by direct combination. By simply combining two elements together, it can give you what? An acid. For example, a combination of your what? Your hydrogen gas plus your chlorine gas will give you what? Will give you what? Hydrochloric what? Acid. By direct combination. Direct combination is simply talking about what? Bringing two elements together combining them to give you an acid. Another method of preparing an acid is by what? Acid anhydride. Acid anhydride. Acid anhydride. Your carbon dioxide and acid anhydride. Carbon dioxide. If I combine carbon dioxide with water, it will give me an acid. Let's find out. Carbon dioxide, CO2 plus water, H plus water, H2O. What will this give me? What will be this product? H2CO3. This is an acid. There is a weak acid. This is a weak acid. Thiazocarbonate. Thiazocarbonate 4 acid. Thiazocarbonate 4 acid. I was trying to calculate the oxidation state. 3 times 2, 6 minus 2, 4. Thiazocarbonate 4 acid. This is a weak acid. Let's try another type. Benzene balanced. Let's observe it. Is this equation balanced? Yes, it's balanced because we have one atom of carbon, 2 atoms of oxygen plus this one, 3 atoms of oxygen, 2 atoms of hydrogen, 2 atoms of hydrogen is balanced. Let's try another acid anhydride. Let's combine this with what? Water. This will give us what? H2SO4. Sulfuric acid. Dissolving an acid, combination of an acid anhydride with water. That's this one. This one is direct combination, bring 2 elements. This one is combining acid anhydride with what? Water. Our superscript is triazosulfate plus water gave us what? Sulfuric acid. Is it balanced? Let's check. Yes. 1 atom of sulfur, 1 atom of sulfur, 3 atoms of oxygen plus this one, 4 atoms of oxygen, 2 atoms of oxygen, 2 atoms of hydrogen, 2 atoms of hydrogen. So these two methods are ways of preparing an acid. I will end this video by telling you some of the uses of acid. Some of the uses of acid. Use of acid. Acid can be used in making explosives. Explosives can be used in the production of paints. It can be used in the production of detergents. It can be used for baking. It can be used in oil refineries. It has what? Several what? Functions. So these are some of the what? Uses of what? Acid. I'm going to end this video now. In the subsequent videos, you watch out and check out for what? Base and what? Salt. If you find this video helpful, subscribe to my channel, share and like this video. Thank you.